This is more of a valuation of the U.S. cellular state more than anything else. So, favorite color. The color squares next to each one of these were not added by the students. They were not added by the software. I added them to this presentation for visual effect. You can see that there were 4 groups that resulted from the algorithm, and there are most definitely more than 4 colors on the screen. The blue and the navy blue are together, but the algorithm put together teal and pink and purple. The fact pink and purple look similar have nothing to do with why they're together. It put green, yellow, and red together. And it also put orange and black together, which is interesting because they don't share any characters really other than that A. So that is definitely a failure. But again, there is hope. In interim step of the algorithm, this is the order of the merges. An interim step of the algorithm did have the correct result. There was the desired result, however, the heuristic used to stop the algorithm simply failed. It kept merging them together, and again, you end up with what almost looks like a random result at the end. Home state, this was also a promising example. These are all of the groups. You can see that there are 9 groups that were created, but there was a failure here. MO was recognized with a space in it, and that KY right there was actually recognized as the word rut. I'm not quite sure where rut came from.
Which KY?
That KY right there was recognized as rut. That was a failure of the handwriting recognition algorithm. I expected those, but why rut went with MO is they were both short strings. I believe that's why the algorithm merged those together. So you can see here that all the Kentuckys were not put together, but a vast majority of them were, so that's very promising. And not all the KYs were put together, but still the majority of them were. So the results, while not perfect, are extremely useful. And again, you can see the mergers. Again, many of the, I believe one of the Kentuckys was the word fantasy. I recognized Kentucky as the word fantasy. So when the handwriting recognition fails, it can fail in interesting ways as well. So, handedness. Unfortunately, I might be left-handed, but my sample group did not have that many left-handed people in them. So the first group was actually so large I had to split it into 2 columns. There were 2 other groups. Right-handed, there were a double question mark, and the left-handed actually got merged in with right. And then there was a right-handed group. So again, not perfect, but in general, the results were fairly promising. Again, those were separate. The algorithm failed to identify that no merges should occur, so the heuristic failed. So some conclusions. There are 3 distinct parts of this approach. One is the turning the ink into some type of object that's useful. In my case, handwriting recognition. And the handwriting recognition algorithm proved to have very sufficient level of accuracy. While it might not be perfect, and when it fails, it might fail in interesting ways, the level of accuracy was very high. So using that approach was suitable, especially the time performance. While I made the algorithm run on multi-core and utilize as many cores as the CPU had, even if I had not done this, the algorithm would have converged and run in only a few minutes maximum on a slow computer. On a fast computer, it's a matter of seconds. Additionally, the clustering of string distances the clustering based on string distances was appropriate. Even when it failed, the early merges were accurate and were sufficient, and it produced useful results. However, the heuristic to identify the stopping condition was less than perfect. Oftentimes, it completely failed. And a point that's also important to make is it would be possible for the identical set of answers provided by students, and you could have 2 different questions that could elicit that same set to have different ideal clustering. So it really takes a human's knowledge to understand what is the best ideal clustering. Because given a set of answers, there is no ideal clustering. You really need the context of the question. So human understanding and human interpretation is still a vital part of this. So some future directions, Windows 8 will introduce hopefully an improved version of the math input library. It would be very exciting to utilize math input and perform recognition on math input. That introduces a whole set of problems with computer algebra systems. In those cases, you might want to match exactly. However, the integral from 0 to 6 might actually be equivalent to the integral from 0 to 8 because the ink was recognized wrong. So you actually have to introduce a level of blurriness and allow for some mistakes and some margins that computer algebra systems simply aren't designed for. Additionally, not only does the clustering algorithm need to be able to prompt for human feedback, but the interface needs to as well. There is the possibility of having a computer be able to solve this in all circumstances is simply not possible at this point in time. It requires human-level knowledge to know what the intent was. And if the algorithm could pose very appropriate questions to the human and say, are these two things the same? Should these be separate? What should I do in those cases? And if the interface made that easy, the time required for grading would obviously be decreased. Are there any questions?
I was, there were me thinking about this. One of the things, if that equation on page 34, I believe, the one that the cost equation, it would be interesting if you look at some weights.
Yes, that is
and that might be a way to, improve on it. And I was looking at your algorithm too, and this over merging. If there is a way you could put like less than and greater than, maybe add another condition that actually will tell it, because obviously it's getting to a certain point that it does grouping fine, and then it get ambitious and starts grouping more, and you end up, so if there is a way you could say, well, if you get to that point, then maybe it's time to stop, but I don't know how to do that.
So one of the problems I had is the data sets that I was using were completely synthetic. I made up answers and I said, well, maybe some students would answer a question this way and maybe they would answer this way. My favorite example to go back to was cat, cats, a cat, the cat, dogs, dog, a dog, the dog, where there's just a little bit of variance and they should go into two groups. So what would really help with that problem is having collections of real student work that were collected with questions. In mine part, I believe part of this boils down to English language and students' tendencies. So improvements to this would really be gained by looking at real data sets of real student answers and attempting to mine out the best equation for that. And is there a one-size-fits-all equation for this? Maybe not, because in some cases, one grouping might be better than another grouping. And forcing the user to change the cost equation might be a little too much to ask, but if there were presets for, I expect there to be 5 different groups from this, even setting the number of groups, having it be more like a k-means clustering algorithm would be possible.
No, the idea of actually weights and the experimentation of weights is something for the future work to be considered.
Except that negative number messes with.
No, that's actually it will be included in the weight.
Right. So you have a negative weight.
Yeah,
so you just have.
So it could be.
But then
I think that a data set to work on is the biggest hurdle there. And it's kind of, how they did the data sets for the intrusion detection stuff.
Yes.
Need something like that for a mechanical set for people to work on.
Well, what are you thinking about using that, like, as far as an application for elementary? What kind of?
So obviously the math would be very attractive for calculus, physics, chemistry, and even computer science. There's a lot of applications there. For this, it would be more along the lines of like a history class or a quiz where you had to answer just name this person, name this concept. So it could work at elementary levels. The handwriting recognition might be there, but even at the collegiate level, classes where even just putting the letter A, letter B, there would be some use for this. Short answers where a few words that could describe the question would be appropriate.
So you got to account for basically spelling errors, though.
So yeah, this is not designed to be a spelling test.
I think they're putting Dino is really kind of reaching out to the K through 12, and there's increasingly schools that are doing this. And I think there's some real applications for this in the lower level.
In the lower level.
We certainly were more interested in the math piece, but the technology is just not quite there.
In the math piece, or in the math in general, like low-level mathematics, before mathematics, arithmetic. So, for example, the recognition of strings of numbers actually will be something to be considered, and the collection of data that actually resemble certain classes of data, not like what we experimented with synthetic words, to be like, for example, as I said, in arithmetics, there are, for example, rational arithmetics, like kids who are studying how to do arithmetic on rational numbers, like half, 3/11, or something like that, okay, and how they write this ratios, okay, and how a system like this could be used to recognize and cluster them, as well as in algebra, like x squared minus 5xy, something like that. So there is a bank of data that work with this kind of data. That would be a wise thing to do. If we go to calculus, we can have.
Then you get
yes.
really good. You're right. I hadn't thought about the really arithmetic and
The
algebra.
arithmetic.
Yeah.
As long as you didn't have powers, you could do.
Yeah,
you could do an
so
awful
you
lot
can
of really
actually
basic stuff
split it
with existing
into-
handwriting
Yes.
recognition.
Yes, you can actually work from